Typically, you will find three different scenarios for reorder point with normal probability variation for the demand. Okay, so the first case is, of course, both are constant. Demand is constant, standard deviation is constant, the lead time is constant, and we did that early on. So just D times L, and that's it. There is no safety stock. But when safety stock needs to be added, so these are the three possibilities. You have demand is variable, but lead time is constant. The demand is constant, but lead time is variable. Or both demand and lead time are variable. So these are the three situations, and here D times L is still the mean. So the mean is the same formula like before. The only difference is in the formula for standard deviation of demand during lead time. Okay, so here is the formula when demand, so that's your standard deviation for demand during lead time. When the demand is variable, lead time is constant. And this will be the formula when the demand is constant, lead time is variable. Okay, now this is the formula, the most general case where both demand is variable and lead time is variable. Of course, so you put that bar on top to indicate that that is the variable part. Now what we can do is we can set up this formula with this, and then if the demand is constant, this will be 0. If the lead time is constant, that will be 0. Otherwise you will have values for both of them. So that will work. So we can just set up one formula and use it for all three cases. So if the demand, if one of the two is constant, you just put 0 for the variance or for the standard deviation. Okay. So let's look at examples. So this company has 3 different items, so each with a different situation. So first one is 5402. The daily demand is normally distributed with a mean of 15 and standard deviation of 3, and the lead time is constant, exactly 4, and we want 97% service level. So here for 5402, so we have average demand of 15, standard deviation for demand is 3, lead time is constant 4, so your standard deviation for lead time is 0. So service level is 97%. So demand during lead time is the average demand times average lead time. Of course, lead time is constant. So, right now, Z value is norm.s.inv of that service level. Next, we have to set up the standard deviation. Okay, so here is the standard deviation formula. So that will be square root of L. Okay, so that's that. Okay, times sigma sub d squared, and then plus d squared times sigma sub L squared. Okay. So when you use that general form of the formula, then you can just copy that for all the other problems as well. Safety stock then is Z times the standard deviation of demand during lead time. So which is that. And then reorder point is demand during lead time plus safety stock. Okay. Now the next item, okay, so which is 7319. So here 7319. So the demand is constant and the lead time is normally distributed with a mean of 6 and standard deviation of 3, and we want 98% service level. So Demand is constant 25 and therefore standard deviation is 0. Lead time is 6. Standard deviation for lead time is 398. So now, since the relative position of the formulas are same, so we can actually copy paste that, and we will have the answer. So this is D times L, and then the Z value, okay, just to be sure that everything is okay. All right, so that's our standard deviation, and then Z times standard deviation gives a safety stock, and that plus that will give you the reorder point. Okay, then third one, F9004. Okay, the demand is normally distributed, mean of 20, standard deviation 4. Lead time is normally distributed, mean 5 days and standard deviation 2. Okay, and we want 94% service level. Okay, let's enter the values here. Okay, and again we can copy these formulas down here, and we have the ROP. So once again, let's check it out, make sure. So D times L, Z value for 94%, then standard deviation, Z times the standard deviation is safety stock, and ROP is demand during lead time plus safety stock. Okay. Now let's look at cost of safety stock. The cost of safety stock actually increases as your service level increases. Okay, and as you get close to 100%, the cost of safety stock increases quite significantly. So that is illustrated by looking at the first item that we saw. So that is here. All right. So let's get that information transferred here. Okay. So 350 demand during lead time, 10 standard deviation, 95% service level, carrying cost per unit, let's assume that it's $2. Okay, so your textbook says that. So these three plus cost of inventory is $2, right? And then we'll set up the Z value and safety stock. We can go all the way up. Well, let's do this separately here. So norm.s.inv of that. So that's our Z, and Z times standard deviation, that's the safety stock. ROP is average demand plus safety stock. Okay. Now what we want to look at is the cost of safety stock, right? So cost of safety stock is safety stock times the carrying cost. So carrying cost we are assuming is $2 per unit per year. So for 95%, that's the cost. Now what we want to do is look at different service levels and see how the cost of safety stock changes for different service levels. So we can do this using a data table. So let's start with the service level of 90%, right? And then we'll increment by 1%, 0.01. Okay. Then let's go all the way up to 99%. And then we will add one more, say 99.99%. Okay, so even closer to 100%. Let's all right. Now we want to look at the safety stock and cost. So we will, the first row being blank, we'll enter the formula for safety stock, cell reference formula for safety stock here, and the cost of safety stock here. So now highlight the entire area, and then okay, so make sure that the first row is included and these percentages are included. Data table, and here our input values are the service level. Okay, so that's in a column. So this is a column input cell, and that's where our service level is. So our column input cell is C65. So then we have the results, right? So these are dollars. Now let's plot these dollars, okay, starting from 90% service level. So let's say we do a line plot, and you see that as okay, let's enter the service levels here for x-axis. Okay, so that will be cost of safety stock versus service level, right? Okay, see, as you go higher and higher, then there is a point where it becomes exponentially higher as you increase the service level.